Hi everyone. All right, in this video I want to go over sample exam number 3A, which is estimation. You're gonna do this a little bit fast because the answers are pretty straightforward and you have the solutions. But let's start. The first three problems are conceptual problems. So now I let you read the first three questions and read the answers. So go over this, and I just brought the solution here for you. And please read those. So these are pretty fast. So we won't spend so much time on this recording. So, but let's start with calculations. I want to explain the calculations. So let's start with number 7. Number 7 says find the critical values z sub alpha over 2 that corresponds to 94% confidence level. One more time, 94% confidence level, that means this area in the middle is 94%. To find the critical value, that you have to know that red area. So you do 1 minus 0.94 divided by 2 is 0.03, and this is a z value. So you go calculator, you go to inverse norm 0.0301 and you get negative 1.88, but the critical value always take the positive one, so it's 1.88, and D is the answer. Number 8, the following confidence interval is obtained for a population proportion which is p is between 0.537 and 0.563. Use this confidence interval limits to find the point estimate p hat. So we know the first number here is p hat minus e, and the second number is p hat plus e, because as we said, p is a number between p hat minus e and p hat plus e. So p hat minus is 0.537, p hat plus is 0.563. You write this, and this is like a system, two unknowns and two equations. You can add those equations. You can add 1 and 2. If you do 1 plus 2, p hat plus p hat is 2 p hat, and these two cancel each other, and the 0.537 plus 0.563 is 1.1. So you want to solve for p hat, you divide both sides by 2 and you get 5.55, and D is the answer. Number 9, assume that a sample is used to estimate the population proportion P. Find the margin of error E that corresponds to the given statistics and confidence level. Round the margin of error to 4 decimal places. Now, first of all, 98%, again, we know this is 98%, the area in the middle. We need to know this red area. As I told you, so you do 1 minus 0.98 divided by 2 is 0.01. Use your calculator. Inverse norm 0.0101, you get negative 2.33. The margin of error is given by this formula. Z sub alpha over 2 times square root of p hat q hat over n. 2.33, we found that. And let's see, 25%, so p hat is 25 and q hat is 1 minus 0.25, we all know. So 0.75, use your calculator, you get 0.0338, and A is the answer for this one. Number 10, use the given degrees of confidence and sample data to construct a confidence level for the population proportion P. So 98% we learned, Z sub alpha over 2 is 2.33. So p hat in this case is x over n. So it's going to be 46 over 97, which is 0.474. The interval is given by this formula p hat minus c, p, and p hat plus c. and we know Q is 1 minus P, which is going to be 0.526. So find the margin of error first if you want to use the formula. So it's z sub alpha over 2 times P squared up P hat Q hat over N, 2.33 times 0.474, and Q is 0.526 divided by 97 because N is 97, and you get 0.118. Use the formula 0.474, which is P hat minus E, which is that 0.118, and less than P, and less than 0.474 plus E, which is 0.118 again. And if you do that, you get this answer, which is C. So C is the answer. If you want to use your calculator, press that, choose test, and go to A1 prop Z test, and it's very straightforward. The calculator is going to ask you for X and degrees of the confidence level, and you get the same answer. Number 11, use the given data to find the minimum sample size required to estimate the population proportion. Be careful here. So, and the error is 0.004, confidence level 95%. These are unknown. So when P hat and Q hat are unknown, you have this formula, z sub alpha over 2 squared times 0.25 divided by E squared. So you just substitute z sub alpha over 2 is 1.96 squared times 0.25 divided by 0.004 squared. And again, the formula N is z sub alpha over 2 squared times 0.25 divided by E squared. And if you do that, you get exactly 60,025. So B is the answer. Next, same thing. They want the sample size. Margin of error 0.05, confidence level 99%. In prior study, P hat is estimated to be 0.15. Here, P hat is given. So you don't put 0.25 anymore. So the margin of the sample size will be N equals to Z sub alpha over 2 squared times P hat times Q hat over E squared. 99% confidence level, we know Z sub alpha over 2 is 2.575 squared times 0.15 times 1 minus 0.515 is 0.85. Divide by 0.05 squared. If you do that, you get 338.16. Be very careful because for sample size, we always take the next whole number. Even do not round it off, round it up. So N is going to be 339, and D is the answer. Number 13, when 319, well, let's see what it says. Use the given degrees of confidence and sample data to construct a confidence interval for the population proportion, P. When 319 college students are randomly selected and surveyed, it is found that 120 own a car. Find a 99% confidence interval for the true means population proportion for all college students who own a car. So we are given N and we are given X. We can calculate P hat, which is X over N, and you get 0.376. Again, the formula is P hat minus E less than P and P hat plus E. E is given by this formula, Z sub alpha over 2 times square root of P hat Q hat over N. Z sub alpha over 2 for 99% confidence level is 2.575. P hat 1 minus P hat, you substitute over 319, and that's what you get. So if you use that point, P hat is 0.376 minus 0.0698, we get 0.306, 0.376 plus 0.0698, you get 0.446. And let's get the answer for this one. So the answer 0.446, 0.306, B is answer. So the answer is B. You want to use your calculator. Again, you go to stat, test, and it's one prop Z interval, and it's pretty straightforward. Number 14, of 101 randomly selected adults, 35 were found to have high blood pressure. Construct 95% confidence level for the true percentage. Percentage is the proportion of all adults that have blood pressure. N is given, X is given, you can calculate P hat, which is X over N, and you get 0.347. 95% confidence level, Z sub alpha over 2 is 1.96. Same formula, E equals to Z sub alpha over 2 times square root of P hat Q hat over N, 1.96 times 0.347 times 1 minus 0.347 divided by 101. And if you use your calculator, you get 0.0928. Substitute in this formula. We already went over this in the previous problem, and you get this interval multiplied by 100, so you can get the percentages. Again, for calculator, you can just go stat test, and it's one prop Z interval. Next, use the confidence level and sample data to find margin of error E. Round your answer to the same number of decimal places as the sample mean unless otherwise noted. Okay, let's see. Sample mean is 11.9, so it's the nearest 10. Replacement time for washing machines, 90% confidence, N is 45, X bar is 119, and sigma is given here. So when sigma is given, we know already we're going to use Z. So it's Z sub alpha over 2, 90%. We said it's 1.645 times sigma, which is 2 divided by square root of n. And if you do that, you get 0.49, which is very close to 0.5. So we could pick A. A is the answer. Number 16, use the confidence level and sample data to find the confidence interval estimating the population mean, mu. So let's just read the problem. A random sample of 105 light bulbs had a mean life X bar is 441 hours with a standard deviation sigma. One more time, please notice it's sigma, so we're going to use Z or the normal distribution. Construct 90% confidence interval for the mean life mu of all light bulbs of this type. The interval is given by this formula, X bar minus C, X bar plus C. And E is Z sub alpha over 2 times sigma again, because sigma is given over square root of n. 1.645 sigma is given in the problem, n is given. Use that, you get 6.421, and that's approximately 6 if you look at the answer. So you can do 441 minus 6 less than mu 441 plus 6. And you get 435 on the left side and 447 on the right side, and C is the answer. If you want to use your calculator, you go to stat, test, and pick number 7. This is just Z interval. Enter the givens, and the calculator will give you the interval. And sometimes you take the closest number, so be careful when you check the answers. Number 17, use the given information to find the minimum sample size. So we're looking for the sample size to estimate an unknown population mean. One more time here, the margin of error will be given about the population mean. How many women must be randomly selected to estimate the mean weight of women in one age group? We want 90% confidence level that the sample mean is within 3.7. When you hear the word within the population mean, that means 3.7 is the margin of error. So and the population standard deviation is known to be 28, so this is sigma. The formula for the sample size here, it's z sub alpha over 2 squared times sigma squared over e squared. 90% confidence level, again z is 1.645 squared times 28 standard deviation squared divided by the margin of error we said is 3.7. So you get 154.97. Round up again. This is, even if you round up, you're going to get 155. But just remember, you always take the next whole number when you are calculating the sample size. So B is the answer. Number 18, assume that sample is used to estimate population means. Use the given confidence level and the sample data to find the margin of error. Assume that the sample is simple random sample and the population has normal distribution. Again, these are the requirements and the problem gives you already. Round your answer to one or more decimal place than the sample standard deviation. So 99% confidence level, n is 201, x bar is 276, and s is 75. Be very careful here because s is given. When we're given s, then we have to use t. Do not use 2.575 for this problem. You have to find the critical value. So again, if it's 0.99, the area in the tail is 1 minus 0.99 divided by 2, and that's 0.005. You get negative 2.60 if you use your calculator. Inverse t, 0.005 is the area, and 200 is the degrees of freedom, which is n minus 1. So then you use the positive number to find the margin of error, so is 2.60. Again, that times 75, which is s divided by square root of n. And you get 13.75. And again, the closest number in the answers is 13.8. So B is the answer. Number 19, use the given degrees of confidence and sample data to construct a confidence level for the population mean mu. So, and this is the assumption, I let you read it. We're given a data here. So we have 1, 2, 3, 4, 5, 6 numbers. So we can calculate S and X bar in this case. Use one bar stats with your calculator. If you do that, first put these numbers in L1, then use one bar stats. You can get X bar is you're gonna get X bar is 80.62 and S sub X is just S, which is 6.23. The margin of error, one more time, 90%. Since we calculated S, we have to use T. When you're given a sample, use T. So 90%, the area in the tail is 1 minus 0.9 divided by 2 is 0.05. You do inverse T, 0.055 are the degrees of freedom, which is 6 minus 1. And you get negative 2.2. So the margin of error is going to be 2.2 times 6.23 over square root of 6. You get 5.14. So the mean 80.62 minus is minus 5.14. In the left side, you get 75.49, and 80.62 plus 5.14, you get 85.76. If you want to use your calculator, just go stat test t interval. You can click on stats when you use this and put these numbers, or you can just go, since these numbers are already in L1, just highlight data and then pick L1 and put the confidence level, and the calculator will give you the answer. Number 20, construct the integrated confidence interval for the difference between population proportions, P1 minus P2, assume that the samples are independent and they have been randomly selected. Requirements are given. So here we're given x1 is 22, n1 is 38, x1 is 30, x2 is 31, and n2 is 52. Confidence level is 90%. Now the formula for that is p hat 1 minus p hat 2 minus c. And you have p1 minus p2. And on the right side, you have p hat 1 minus p hat 2 plus c. The formula for E is z sub alpha over 2 times square root of p hat 1 q hat 1 over n1 plus p hat 2 q hat 2 over n2. We always use z anytime we are dealing with proportion or proportions. So again, 90% is 1.645. You can find the p hat 1 and p hat 2 by using these formulas. It's just x over n. If you substitute and use your calculator, you get 0.173. So p hat 1 minus p hat 2 minus e is 0.190. P hat 1 minus p hat 2 plus e is going to give you 0.156. And again, D is the answer. You can use your calculator by going to stat, highlight test, and then go to B, to prop Z interval. The calculator is going to ask you for x1, x2, n1, n2, and the degrees of confidence or the confidence level, which is 0.9, and it's going to give you the interval directly. Same problem here, number 21, x1 is given, n1 is given, x2 is given, and n2 is given. We want 98% confidence level. And this is like exactly like the last problem. However, the critical value is the confidence level is 98%. It's not a common one, so you can find that. Find this area. 1 minus 0.98 divided by 2 is 0.01. Inverse norm 0.0101, so you get negative 2.33, and you can find the margin of error. But if you want to do this fast, you can use your calculator, and I put the steps here. Press stats, pick test, scroll down to B2 prop Z interval. Put this givens, confidence level 0.98, and you get the answer. And again, check the answers and pick the closest one. It's going to be always the right answer. Number 22, construct the indicated confidence level. Confidence interval for the difference between the two population means. So these are, we're not dealing with proportion, we're dealing with means. Assume that the two samples are independent. Simple random samples selected from normally distributed populations. Also assume that the population standard deviation are equal. Very important. If the problem does not mention equal, then that means they're not equal, but here it mentions, so that the standard error of the difference between means is obtained by pooling the sample variance. A researcher was interested in comparing the amount of time spent in watching television by women and men. Independent simple random samples of 14 women and 17 men were selected, and each person asked how many hours he or she had watched television during the previous week. The summary is given in this table. So we have the average numbers for women, the standard deviation for women, and the number of women, the sample size, and same info for men. Construct 95% confidence interval for mu1 minus mu2, the difference between the mean amount of time spent watching television for women and the mean amount of time spent watching television for men. Important note here, mu1 equals to sigma 1 equals to sigma 2 because the problem mentions it. So we need the pool sample variance. The formula I have given it to you, and it's pretty long, so it's much better to use our calculator here. So you can go to stat test, pick 0, which is two sample t interval. When you have S's, you're going to use t, but in this case, it's the pooled one. So you pick the input data stat, you pick stats because this is given in the problem. So you input all this information up to here. Confidence level is 0.95. The calculator is going to ask you for pooled, no, yes, and highlight yes, because sigma 1 equals to sigma 2. So if you see that information, always highlight yes. So then if you do that, you get this interval, pick the closest number in the answers, and D will be the answer. Next one, number 23, construct the indicated confidence interval for the difference between two population means. Assume the two samples are independent, simple random samples selected from normally distributed populations. These are the requirements. Do not assume that the population standard deviation are equal. Do not assume they are equal, and I have to fix this. So let's go. So they're not equal. So note the population standards are, let me fix this. Are not equal. So we use, so again, these are not equal. I thought the problem said they're equal. So we use this formula. X bar 1 minus a minus C, mu1 minus mu2, and x bar 1 minus x bar 2 plus C. So you go to same thing, calculator, stat, test, pick two sample t interval, 0. Put the data, and here highlight no, because sigma 1 is not equal to sigma 2. So, and if you do that, maybe we can try to do this. Let me show you the calculator. So let me stop sharing this. And so let's try this one. We said we're going to go to stat, and then we're going to go to test, and then we're going to go to 0 to sample Z interval. Now, data, we don't have data, we just have stats. So enter that, and here x bar 1 is given to be 19.4. S sub x1 is given to be 1.4. N2 is given to be 35. X bar 2 is given to be 15.1. S sub x2 is 0.8. N2 is 40. And confidence level is 0.95. So we're good here. Again, pooled is no, so you enter that. And let me just double check the givens 30, 19.4 to 35, 1.4, and we have X bar 2 is 15.5, S is zero point 0.8, and it's 40. So again, they're not the set. Sigmas are not equal, so just say no to pool and calculate. And if you do that, you get 3.716 and 4.8. So, and again, B will be the answer here. So this is the interval and B is the answer. So let's go back to our exam. So B is the answer. Number 24 works exactly the same. Well, it's not mentioned, so we assume they're not equal. So you say no to pull, and I put the formula here for you. If you want to use the formula, you can use that. You have to find T sub alpha over 2. And the degrees of freedom here is the smaller of n1 minus 1 and n2 minus 1. So one more time, you just follow the same thing. And you say no to pooled because you know they're not, sigma 1 is not equal to sigma 2, and if you do that you get, this is very close number to D to C, so C is the answer for this one. Number 25 is just constructing the confidence interval for the difference of two population proportions. We did that above, so I just put the calculator command. Again, it's 2 prop Z interval, and if you do that, C should be the answer. I did put the calculator answer here for you. So please, after watching this video, try to take the test on your own and see how you do that, how you do it, and then you can compare the answers. And I think that's it. Hope you all have a good one, and I will see you soon.